Hello there, this is the intern, and today I'm going to discuss about my experiences on data science as an absolute fresher. So I've been studying various fields of data science for about a month now. Not to mention, this has been the best experience in my computer science degree. So what exactly is data science? You have been given, let's say you have been given a huge amount of raw data. Your task is to summarize and extract knowledge from them. Now, data science is not just any small field. It is a huge field consisting of many small, not to say huge, subfields like deep learning, machine learning, and data analysis. So, the thing is that you can learn it all for free on the internet and on YouTube. Now, one thing you guys need to get it right is that you do not need to have a solid base on computer science when you are starting to learn the theory, but you will eventually need it when you are trying to implement the algorithms on your computer. Typically, a data scientist tech stack includes Python and R as their programming language, with libraries like TensorFlow, Scikit-learn, Matplotlib, Keras. You might have heard of these names. I'm sure you have heard of it. Now, how do you actually learn all of this in a limited amount of time? Surely you cannot. Once you are done and dusted with the theory, coding becomes the easier part of a data scientist's job. It becomes way easier to follow up on what you are actually implementing on your computer once you have a good grip on the theory. So I started my journey from Andrew Ng's course on Coursera. It's called Supervised Machine Learning. Now here's the thing. Andrew Ng is regarded as one of the best mentor on the field of data science. Now, this course deals with two problems, the most famous linear regression and logistic regression problems. Now, with many smaller subtopics like regularization and normalization of the dataset. So, why is this important, you might ask? These two topics will make up the base, the fundamentals of your entire career. When you are learning data science, you will be dealing with majorly two kinds of problems. These are regression and classification. The first one is a regression problem. Here you are given a data set of labels and features where you'll first have to fit the data set on various models. The simplest one being a linear regression model, which deals with fitting the data set on a straight line. After the machine fits or learns the dataset, it will learn to predict the best label for an input feature in numbers. Like predicting the price of a house with a specified area, that's the best example I could give you. The second one is a classification problem. Here you have a fixed set of labels to work on. Customer churn modeling is a good example wherein you'll have to decide if a bank customer is going to retain his bank account or close it. Notice that the answer can only be yes or no. Now that your theory is well done, you can get on your desktop and start implementing these algorithms. What I did was initially, for the first time, I implemented these algorithms on C++ from scratch without using any kind of libraries. This helped me understand the inner working of the algorithm, and I faced problems that I should not have faced if I had directly shifted to Python with scikit-learn. You can see here that a multivariate linear regression model predicts almost the same labels in scikit-learn and my C++ program. Now, deep learning is a kind of advanced machine learning architecture which relies on neural networks. Now, neural networks have been heavily inspired from the working of our biological brains. Broadly speaking, there are three kinds of neural networks, and each one of these have their own use case and scenario. The first one being artificial neural network, convolutional neural network, and recurrent neural network. Now, our classic problems of machine learning can be tackled using artificial neural networks, whereas convolutional neural networks generally deal with object detection and computer vision, and recurrent neural networks deal with sequential data like stock prices or the language we speak, making it heavily useful in natural language processing. Now, while studying deep learning, we generally stumble across a wide range of hyperparameters. Now, what in the bloody hell are those? Well, it is what makes a neural network, it is what defines a neural network. You see, each neuron has a particular activation function which requires a particular weight initializer to work properly. Also, there may be different amount of neuron in each layer. If your problem statement is a regression problem, you are most likely to use the linear activation function in the last layer or softmax if your problem deals with classes or is a classification problem. You are also bound to use different loss functions and optimizers according to your problem. You'll find yourself experimenting with all these hyperparameters to try and improve the accuracy and performance of these models, but you cannot keep manually changing the parameters and train them all at the same time, can you? Keras makes it especially easier for you by introducing you to Keras Tuner library. Keras Tuner has an amazing functionality where you can just specify the hyperparameters you want to experiment on, give their functional ranges, and let Keras do the magic for you. After a user defines set amount of trials, it returns you the best fitting model for the data. Now, after finishing off with ANNs, you will be introduced to CNNs, which is convolutional neural networks. Here you will be working with a ton load of images, and the problem statements you will be dealing are quite different. You will be working on image classification, image localization, and image segmentation. Before defining and training the CNN, you will need to pre-process the image datasets. This also requires quite a bit of knowledge from image processing but can be achieved with just a few lines of Python code. You generally convert the pixel values of each channel to a float value between 0 to 1 so that the training process becomes incredibly faster. Now, CNNs are quite different from vanilla ANNs because they work on huge amounts of data with relatively less numbers of parameters. Now, you will need a graphics processing unit or a GPU in short in order to process or train the CNN because they generally take hell lot of time to process. Else, you can simply use Google's Collaboratory, Google Colab in short, to process and train your convolutional networks. You can also use a method called transfer learning where you generally just strip off the last few layers of an already trained CNN and retrain those specific layers on your given data set. This only works when your data and the data that the CNN has already been trained on are quite similar. Now, some amazing YouTube channels that deserve an acknowledgement is Krishnayak and CampusX. Both are amazing channels with a lot of content for data scientists and deep learning enthusiasts. And you can also log into Kaggle, where you can practice your data science skills, stand in competitions, or discuss models with peers. I'm quite new to Kaggle, so don't expect much. To sum it up, data science is a huge field with most of it still in the research phase. It has a lot of potential in the IT sector, and I've not even talked about unsupervised and reinforcement learning yet. So, anyways, it includes a lot of hit and trial to successfully be able to compile your model to check how your model is working on real world images, and you will be learning a lot from reading research papers. You will be implementing a lot of new models that come out every day, like There's a lot of research going on data science, so you'll never get tired of reading new research papers. So that's it for today, and I'll see you guys very soon.